Hello guys, welcome back to our YouTube channel. So remember in the previous video we talk about what triangles, and then so we talk about right angle triangle, we talk about isosceles triangle, and then we also talk about what scalene triangle. And also we realize that when it comes to what a right angle triangle, we can apply what the Pythagoras theorem, right? We can apply the Pythagoras theorem and the SOHCAHTOA in solving what the triangle, right? But then when we talk about the other type of triangle like the scalene and then the isosceles, we can apply what we cannot apply the Pythagoras theorem to and then the SOHCAHTOA, because what they are not right angle triangles, right? So in this video I'm going to show you guys how, or some of the rules that we can use or that applies to this form of triangles. Yeah, that's what we are going to do in this video. So one of those rules is what the sine rule, and then so I'll take you guys through how to like prove the sine rule. So if you consider any triangle in this form ABC, so you realize in this triangle no sides are what equal, no angle is equal, everything here is what different, right? So if we draw a perpendicular bisector of what A what B from what C, you will get what the height, and then you realize that you would divide what the triangle ABC into what two right angle triangles. So the first one will be what ACD, and the second one will be what BCD, right? So that's two triangles that you're having, and then here this side will be what B, since it's opposite to the angle B, and then this side will be what A, since it's what opposite to the angle what A, right? Now from here we can write some simple expressions like sine A. So if you find sine A will be equal to what opposite over what hypotenuse, right? And then so from there you can get the hypotenuse to be equal to what B what sine A. And then if you write what sine B will be equal to opposite over what its hypotenuse. And then when you get the h to be equal to what A sine B. You can see that from here, let's say this is equation 1 and this is what equation 2. The two of them are what equal, right? So you equate them, and when you equate you get what B sine A to be equal to what A sine B, right? So you get that what you get this, and then when you simplify further by dividing both sides by sine A and what sine B, you get B over sine B is equal to what A over what sine A. And this is what the statement of what this is the statement of the sine rule. So this is what the statement of what the sine rule. And if you do the same thing for the same thing, so we realize that you find the perpendicular bisector of what AB, right? If you find the perpendicular bisector of what BC from A, you also realize that you get an expression which looks like this. So when you rearrange you get this, right? So when you consider any triangle ABC with this size, the sine rule states that what the ratio of the size to the sine of the opposite angle, right? The angle that's opposite to it. So A, this is the side, and then the sine of the angle that's opposite, which is angle A, is a constant. Okay, it's a constant which is equal to what B over the sine of what its opposite angle, which is equal to what C over the sine of what its opposite angle. So that's the statement of what the sine rule, and then that's how you can prove the sine rule. So you should also take note of this. Maybe they can ask you an exam to what prove the sine rule, or some question around it will come. So take note, or you can just interchange them since it's a ratio or like it's constant. Changing them will not really affect the outcome of this relation. So now let's see how we can use the sine rule. So you can use the sine rule in two occasions, okay, in two scenarios. We can use them if we are given two angles of what in a triangle and the length of the opposite side of 1. Okay, so we can use, so we have what, two angles, and what, length of what, length of side, opposite side of one of the angle, right, of one of the angle. So we'll see an example of this, right? We'll see an example. So in this question, they ask us to find the what, length A. They ask us to find the length A in this scenario, and from analysis we can see that what, we have the angle B, we have angle A, we have the length of what, the opposite side of what, B. We don't have the length of what, opposite side of what, A. So we can write a relation that involves what, A and B. So we don't have any data on C, so we will not include C in this relation. So when you write that using what, the sine rule, you realize that what, A over the angle which is opposite to it, sine of the angle, should be equal to what, 7 over what, the sine of what, 39. And then from there you can what, do change of subject, and then you get this, and then you get your A to be equal to what, 9.82 centimeters. That's to 2 decimal places. You can get it up to 3 decimal places. That's depending on how they want you to put it. Okay, so this is one scenario of how we can use what, the sine rule. The next scenario is when you are given what, two opposite sides, two sides and one angle, and they're asking you to find what, the other angle, right? So in this scenario, you are looking at what, this example. So we can see from here that we don't know the angle B, but they give us the opposite side of B. We know angle A and its opposite side, so we can write a relationship between what, A and what, B, right? We don't have any data on C. Its angle is not known, its side is not known, so that one will not concern ourselves with it. So when you write that using the sine rule, you get what, sine of what, B, which is what you are looking for, over its opposite side, 8, will be equal to what, sine of 46, which is this angle, over its opposite side, which is what, 6. And then when you solve, you get what, B to be sine inverse of this whole expression, and you get your B to be equal to what, 73.56 degrees to what, 2 decimal places, right? So that is one way of what, solving triangles. That's if they are not what, right angle triangles, right? If they are not right angle triangles, that's when you use what, the sine rule. In the next video, we'll be talking about cosine rule, which is also one of the rules that you use in solving this what, angle.